So let's look at how to do a specific problem. This time we're looking at 7.2 number 12. And you can read it here. In a test of weight loss programs, 40 adults used the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2.1 pounds, with the standard deviation of 4.8 pounds. Construct a 90% confidence interval estimate of the mean weight loss for all such subjects. So they're looking for us to estimate what the actual weight loss would be for everybody that is on the Atkins weight loss program based upon 40 randomly selected adults. And so we'll do that. That will give us a range of value where that true population parameter should be. And we'll take a look and try to answer the last question: does the Atkins diet appear to be effective? So as we go to do this problem, we focus on the question. They want a 90% confidence interval estimate for the mean. So right away we know it's the sample mean plus or minus the error. They've already given us the sample mean of 2.1, so the only thing that we need to do is calculate the error. Well, we only have two error formulas that we're going to need to choose between, and we're not going to choose the one with p's in it, because p's means proportion, and we're not dealing with the proportion, we're dealing with the mean. And so it's going to be this t alpha over 2 s over root n button, or root n formula. So E, let's skip the t alpha over 2 for just a minute. I'll leave some space there. But S, totally given to us in the problem, the sample standard deviation is 4.8. And the n is also given to us. It's 40. So the only thing that we have left to do is identify what this t alpha over 2 value is. So what is that? Well, it's going to be based on two things. We have to go to the right row, and the right row will be determined by the degrees of freedom. DF is my abbreviation for that. So the degree of freedom for us would be 40 minus 1, or 39. So we're going to go to the 39th row, or the row headed by the number 31. And from a column perspective, we want to have a 90% confidence interval, which means that there's 10%, or 0.1, in two tails. Right? Because we're going to have 10% left over that's going to be split within the two tails. That will help me determine the column, and this will help me determine the row. So let's go to our chart, since we haven't done that together yet. We'll go and take a look at this chart. Let me make it big. There we go. And I got to scan down to the T's. Sorry, it won't start me out there. So here's my T table, and if you remember, there were two things that I wanted. I needed a degree of freedom. I needed a degree of freedom of 39 since there were 40 participants, and because it was a 90% confidence interval, I got to go to where there's 10% in two tails. Well, that 10% in two tails I can see right now. That's this column right here. So I want to be in that second to last column, and I want to go down to a row headed by 39. Sometimes it's there, sometimes it's not. Oh, it happens to be there. If it wasn't there, I would go to the closest one, but it's there. If you remember, I wanted to go to the second to the last column. Well, that's this one right here. So if I make that value a little bit bigger, sorry about that, it's 1.685. Notice that that's in the 39th row, and it's in the column headed by 10% in two tails. So let's remember that number again, 1.685. So let's go back over to our work in number 12, make it big again. Oops. And come in here and say, well, the only thing I was missing, and I'm going to come in here, I'll put it in maybe a red color, was, I already forgot it, 1.685, I think. Let me go back and double check. Embarrassing, but happens. So let me scan this, and oops, I got to get in there. Maybe. There we go. And apologize because I forgot. So let's see. Yeah, 1.685 is correct. Should have written it down on the side. And so if I come back in here, 1.685 is our guy. And so here we are. all we have to do is calculate that error. So I'll do that off to the side. So we got 1.685 multiplied by 4.8 divided by the square root of 40. You should be able to just type it in as you see it. And we're coming up with an error of 1.278. And then it just keeps going. So we're almost done. And here's what we need to do. Let me switch back over to the black color. We need to take our 2.1 and add and subtract our error. So it's up to you how you want to add and subtract that error in terms of how you want that error to be represented. Sometimes the book will go out to one decimal place beyond what the original date is, and sometimes they'll round exactly. So I was just looking at what they had in the book, and they're going to round it to 1.3. So my error is 1.3. That was the only value I needed to know. So if I take the 2.1 minus the 1.3, I get a low value of 0.8 pounds. Less than, and I get a high value if I add it to it of 3.4 pounds. Now what is that range trying to estimate? It's trying to estimate the population mean. We know what's happening for the 40, so we know their X bar was 2.1, but we have no idea what it'd be for every Atkins weight loss person. And so anybody that's on the Atkins weight loss, we're expecting the average weight loss to be above 0.8 pounds, but less than 3.4 pounds. And so if I wrote that in a sentence, it would be this: we are 90% confident that the true mean weight loss of all Atkins diet participants is between 0.8 pounds and 3.4 pounds. So think about what that means from their last statement, right? Their last question is, does the Atkins diet appear to be effective? They're going to say, yes, it's effective. And that is because we've just shown that you're going to experience, on average, a weight loss. Maybe not much in your eyes, but because there was a weight loss involved on average, and its minimum value is going to be 0.8, and we're 90% confident about that. So its minimum value is 0.8, so you're guaranteed to lose, not guaranteed to lose some weight, we're guaranteed that the average weight loss will be between 0.8 and 3.4, which means on average people are losing weight. Now what we might do advertisement wise is say, hey, on the Atkins diet it's been clinically proven that you lose weight, that on average people lose weight, and the average weight loss can be as much as 3.4 pounds. So we'll highlight that upper value. But we're able to say that because we're absolutely positive that we're going to experience on average a weight loss. At least I should say 90% positive, 90% confident. Hopefully that makes sense to you and meshes with the other problems that you'll see from that section.